During protein synthesis, the base sequence of an mRNA is translated into the amino acid sequence of a protein. This process is accordingly termed translation. Ribosomes are the main component of the translation machinery. During the initiation phase, ribosomal subunits assemble with the mRNA to form a complex. Now, the ribosomes catalyze the linking of amino acids to a peptide chain. The amino acids are transported to the ribosome by transfer RNAs, in short, tRNAs. This complex process requires additional regulatory proteins, which are, however, not shown here. In contrast to cytosolic proteins, secretory, lysosomal, and transmembrane proteins have a signal sequence. It tags these proteins for the rough endoplasmic reticulum, where their translation is completed. If a signal sequence is synthesized, it's bound by the signal recognition particle, in short, SRP. The SRP stops translation and binds to the SRP receptor located in the endoplasmic reticulum membrane. As a result, the SRP ribosome complex and translocon come in close proximity. The translocon is a complex of transmembrane proteins, which opens like a channel once the SRP ribosome complex binds. SRP is released and can now be recycled. Translation continues so that the protein is synthesized directly into the lumen of the endoplasmic reticulum. During translation, the signal sequence is cleaved off the growing protein by a signal peptidase. The cut signal sequence exits the translocon laterally into the endoplasmic reticulum membrane and is subsequently degraded. Following the termination of translation, the ribosome is released back into the cytosol. The translocon channel closes, and the fully synthesized lysosomal or secretory protein is now located in the lumen of the endoplasmic reticulum. From here, it's transported via vesicles by the Golgi apparatus to its target destination. One exception is transmembrane proteins. They're synthesized at the rough endoplasmic reticulum similar to lysosomal and secretory proteins. However, they leave the translocon laterally directly into the endoplasmic reticulum membrane instead of being released into the lumen.